So in the ancient past, we have some indications that water was flowing on the surface, but how much water was there? We're talking about oceans, are we talking about small rivers, little rain? So these definitions of how much water was on the planet was very undefined.
A major question has been how much water did Mars actually have when it was young, and how did it lose that water?
The findings indicate that only 13% of an ancient ocean remains on the planet today, now stored in the polar ice caps. 87% of this ocean has been lost to space. This means that early Mars would have looked much different than it does today, with a significant portion of its surface covered by water.
So the really interesting question is, could it form a sea or an ocean? And indeed, it would. In the northern plains, which is a relatively flat region but depressed from the rest of the planet, it would form an ocean that was approximately 20% of the planet's surface area. And so that is a respectable ocean.
This ocean had a maximum depth of around 5,000 feet or around 1 mile deep. It's deep, not as deep as the deepest points of our oceans, but comparable to the average depth of the Mediterranean Sea.
By combining Martian topography with the new estimate for water loss, the researchers were able to simulate Mars's ancient ocean and its escape to space. As Mars lost its atmosphere over billions of years, it lost the pressure and heat needed to keep water liquid, causing the ocean to shrink and recede northward. The remaining water eventually condensed and froze over the north and south poles, giving Mars the ice caps that we see today.
We now know that Mars was wet for a much longer time than we thought before. Curiosity shows it was wet for 1.5 billion years, already much longer than the period of time needed for life to develop on Earth. And now we see that Mars must have been wet for a period even longer.
It's fascinating that we can learn so much about 4.5 billion years ago what measurements are taken right now. And ultimately we can conclude this idea of an ocean covering 20% of the planet, which opens the idea of habitability and the evolution of life on the planet.
Building on this knowledge, scientists are developing the next series of robotic probes to be sent to Mars in the coming years. This time, NASA is building on its successes, utilizing hardware and systems that they know will work.
We've been to Mars before with the JPL Lockheed Martin team. We've been to the surface of Mars before successfully with Phoenix. We know how to operate the arm. The surface operations are much, much simpler than Phoenix. And we're putting 2 instruments on the surface, and then we're leaving them there with no ground-in-the-loop interaction, repetitive, weekly uplink-downlink sessions. We're just made to do this mission.
The InSight mission is a geophysical mission to Mars. It's going to go to Mars and take its vital signs. It's going to take its heartbeat, the seismic activity of the planet.
So we're going to be doing that using a seismometer, a very high-precision seismometer, using techniques that have been well developed on Earth to get the understanding of the crust, mantle, and core, and sort of the relationship between those.
It's going to take its temperature by measuring the thermal gradient of the surface, which tells how much heat is coming out.
We also have a heat flow probe, we call it HP cubed. And what that does is it's going to basically take the temperature of Mars, and from that it'll be able to understand what the thermal flux is over the course of a full Martian year.
And it's going to sort of measure its reflexes by looking at how the rotation wobbles with the tidal effects of the sun.
Our final experiment is called RISE, and that's going to be looking at basically the wobble of Mars to help understand what the core size may be and composition.
The European Space Agency is also well along with ExoMars, a rover with advanced drilling capability due to be launched by 2018. Its principal goal? To drill down deep in search of microorganisms.
What is new with ExoMars, with the rover in particular, is what we call the mobility. Mobility not only horizontal, but also vertical. And this is a peculiar thing that we have on board the ExoMars mission. So we will be able to sample material from below the surface. That is quite important to understand if there is any sign of past life activity on Mars.
We will be looking for the first time in the 3rd dimension, the 3rd dimension being depth. And we think that is where we have the highest chance of making an interesting discovery regarding the presence of organic molecules in Mars.
It's a whole planet out there with a complicated history. That history is a story that's stored in the rocks, and our job is to figure out that story and what that story of that planet tells us about this planet that we live on.
So where Curiosity takes rocks and grinds them up into powder and looks at their bulk constituents, what this mission would need to do is be able to look in a microscopic level and examine the rocks for these very tiny and detailed messages that they would be sending to us about the past life that could have lived there.
This that I'm holding up here is a classic biosignature from the Earth. It's a fossil. We're not actually expecting to see a fossil of shells or other components, but what we want to be able to see are, with this instrumentation, are the fine scale layering that one might see in a rock, in which we can see dark and light toned layers. And those dark and light toned layers are telling a story.
When will NASA send astronauts to Mars?
4, 3, 2, 1. And liftoff at dawn, the dawn of Orion, and a new era of American space exploration.
The first test flight of the Orion crew capsule is complete. The hardware and systems are ready for mass production. The components, the engineering, the manufacturing are all underway, with NASA looking back to what worked in the past and utilizing it for the future. The solid rocket booster technology straight from the space shuttle has been extended and tested. NASA's new Space Launch System, or SLS, is coming closer to fruition, reusing the space shuttle's main engines as the new system's workhorses, saving millions of dollars and years in research and development. The Europeans are teaming up with NASA to provide the service model for Orion, allowing for long-duration, deep space flights. Autonomous Martian landing systems are well advanced and being tested. Software and hardware are fully integrated for both manned and unmanned Martian landings. And when they get there,
Desert RAT stands for Desert Research and Technology Studies. This is a group of engineers and scientists.
We're looking to test out new concepts, procedures, equipment, like rover concepts, to see how they work in the field environment.
So the team tests these technologies to make sure that in future human spaceflight missions, we'll be able to do science as best as we can. That's something that NASA's never done, 2 human rovers at the same time. So we're really trying to develop how do you use these assets at the same time, and interesting things that you might not think about are your communications. So you potentially have 4 astronauts talking all at the same time to a mission control or science communication background.
It's just like running a real mission, say, you can think about the Apollo mission to the moon. You had the astronauts to the moon and you had people mission control, but there was a science background you didn't hear about, but the astronauts were getting information from them.
Arizona has a very good climate for these types of analog studies. You have pretty much open plains, and you have a lot of geological features that are analogous to places on the moon and on Mars.
long-term space voyages are being replicated on the ground and in orbit with the ISS. Surface habitats, power systems, food and oxygen supply manufacturing are also on the drawing board.
The human flight component would like to see an experiment where resources on the surface of Mars from the rocks or the atmosphere could be used to generate fuel or other parts that would enable future exploration in cutting the tie, so to speak, to Earth. So you wouldn't necessarily have to bring everything with you. You can actually manufacture it on the planet. And that's a really exciting additional component that we've been exploring and analyzing in this work.
NASA isn't the only one with its eye on this prize. ESA and now the Indian Space Research Organization have a spacecraft orbiting Mars, and they did it on their first attempt. Private enterprise is hard at work as well. Mars 500, Mars One, the Mars Society, Mars Foundation, and the Mars Initiative, to name a few. And they have volunteers lining up already for a one-way trip to Mars. It is inevitable that we will set foot on Mars in the very near future. We will stay and learn her secrets. Perhaps in the future we will be able to alter the atmospheric density through terraforming and return Mars to the world that it once was, awash with oceans and rivers, clouds and rain. Maybe some of us could call it home.